In computer programming, a variadic function is a function of indefinite arity, i.e., one which accepts a variable number of arguments. Support for variadic functions differs widely among programming languages. There are many mathematical and logical operations that come across naturally as variadic functions. For instance, the summing of numbers of the concatenation of strings or other sequences are operations that can logically apply to any number of operands. Another operation that has been implemented as a variadic function in many languages is output formatting. The C function print and the common Lisp function format are two such examples. Both take one argument that specifies the formatting of the output, and any number of arguments that provide the values to be formatted. Variadic functions can expose type safety problems in some languages. For instance, C's print, if used incautiously, can give rise to a class of security holes known as format string attacks. The attack is possible because the language support for variadic functions is not type-safe. It permits the function to attempt to pop more arguments off the stack than were placed there, corrupting the stack and leading to unexpected behavior. As a consequence of this, the CERT coordination center considers variadic functions in C to be a high-severity security risk. In functional languages, variadics can be considered complementary to the apply function, which takes a function and a list sequence array as arguments, and calls the function with the arguments supplied in that list, thus passing a variable number of arguments to the function. Related subject in term rewriting research is called hedges, or hedge variables. Unlike variadics, which are functions with arguments, hedge a sequence of arguments itself. They also can have constraints to the point where they are not variable length, thus calling them variadics can be misleading. However, they are referring to the same phenomenon, sometimes mixing together, resulting in the names such as variadic variable. Note double meaning of word variable and difference between arguments and variables in functional programming and term rewriting. For example, term can have 3 variables. One of them is hedge, thus allowing to take 3 or more arguments. Example in C. To portably implement variadic functions in the C programming language, the standard stdog header file is used. The older Variags header has been deprecated in favor of stdog h. In C++, the header file stdog is used. This will compute the average of an arbitrary number of arguments. Note that the function does not know the number of arguments of the types. The above function expects that the types will be int, and that the number of arguments is passed in the first argument. In some other cases, for example print, the number and types of arguments are figured out from a format string. In both cases, this depends on the programmer to supply the correct information. If fewer arguments are passed in than the function believes, or the types of arguments are incorrect, this could cause it to read into invalid areas of memory and can lead to vulnerabilities like the format string attack. stdog h declares a type Virginia_list and defines 4 macros: Virginia_start, Virginia_arg, Virginia_copy, and Virginia_end. Each invocation of Virginia_start and Virginia_copy must be matched by a corresponding invocation of Virginia_end. When working with variable arguments, a function normally declares a variable of type Virginia_list that will be manipulated by the macros. Virginia_start takes 2 arguments, a Virginia_list object and a reference to the function's last parameter. It initializes the Virginia_list object for use by Virginia_arg of Virginia_copy. The compiler will normally issue a warning if the reference is incorrect, but will not prevent compilation from completing normally. Virginia_arg takes two arguments, a Virginia_list object and a type descriptor. It expands to the next variable argument, and has the specified type. Successive invocations of Virginia_arg allow processing each of the variable arguments in turn. Unspecified behavior occurs if the type is incorrect. There is no next variable argument. Virginia_n takes one argument, a Virginia_list object. It serves to clean up. If you wanted to, for instance, scan the variable arguments more than once, you would reinitialize your Virginia_list object by invoking Virginia_end and then Virginia_start again on it. Virginia_copy takes two arguments, both of them Virginia_list objects. It clones the second into the first. Going back to the scan the variable arguments more than once example, this could be achieved by invoking Virginia_start on a first Virginia_list, then using Virginia_copy to clone it into a second Virginia_list. After scanning the variable arguments a first time with Virginia_arg and the first Virginia_list, you could scan the variable arguments a second time with Virginia_arg and the second Virginia_list. Don't forget to Virginia_end the clone Virginia_list.